My goal for this lab lesson today is to help you conceptualize the gyri and the sulci that define the surface features of the human brain. When we look at the adult human brain, it's hard to appreciate what is consistent from one specimen to the next and what's different. This lesson is all about the consistencies, and once you conceptualize those consistencies, it will be just a wonderful experience to appreciate what's different from one brain to the next. When you look at the surface features of the brain, the gyri and the sulci, we see patterns, and these patterns are analogous to the fingerprints on each of your digits. Those fingerprints have standard patterns for each digit, but in each individual, of course, we know that our fingerprints are quite distinct. Something similar can be said of the surface features of the cerebral hemispheres. There are, in fact, primary sulci and gyri that are present in every normal human brain. And then there are secondary and tertiary gyri that help define those distinctive qualities of the surface pattern in each cerebral hemisphere. So we're going to focus on those primary sulci and gyri. And I think a great way to conceptualize the organization of the cerebral hemispheres will be to actually allow you to see how I place my fingers on the gyri of the cerebral hemisphere. And I want you to imagine that my fingers are gyri and the space between my fingers are sulci. So let's begin with the central sulcus. The central sulcus is right near the middle of the hemisphere, and it's defined by two roughly parallel gyri, a precentral gyrus and a postcentral gyrus. So my index finger is representing and overlying the precentral gyrus, my middle finger is overlying the postcentral gyrus, and the space between my fingers represents the central sulcus. Now, while I keep those two fingers there, I want to demonstrate for you the remaining gyral features of the frontal lobe. And to do that, what I'm going to do is place three fingers in parallel that are roughly orthogonal to this central sulcus. So I have a finger down below, which is overlying the inferior frontal gyrus, a finger in the middle that's overlying the middle frontal gyrus, and then a finger up on the top of the hemisphere that's representing the superior frontal gyrus. So three fingers representing three roughly parallel gyri that are meeting the central sulcus almost at a right angle, a little bit more obtuse than a right angle. So now let's look at the parietal lobe. I'll reestablish the central sulcus with my left hand. So now my middle finger is representing the precentral gyrus, and my index finger is representing the postcentral gyrus. And to conceptualize the parietal lobe, all I need to do is place two fingers that are running, again, roughly at a right angle to the central sulcus. My index finger is near the dorsal margin of the hemisphere. We call that gyral formation the superior parietal lobule. And my middle finger is just below the superior parietal lobule, representing the inferior parietal lobule. The space between them is a prominent sulcus of the parietal lobe called the intraparietal sulcus. Okay, now let's move to the temporal lobe. In the temporal lobe, just as we did for the frontal lobe, we can conceptualize this lateral surface as being comprised of three long parallel gyri. So we had three long parallel gyri in the frontal lobe, and we have three long parallel gyri in the temporal lobe. We have a superior temporal gyrus, a middle temporal gyrus, and an inferior temporal gyrus. And the two spaces between my three fingers would be the superior temporal sulcus and the inferior temporal sulcus. Now with this specimen, the brainstem and the cerebellum are preventing me from conceptualizing the inferior surface of the brain, so I'm going to opt for an additional specimen to extend the placement of my fingers to the inferior surface of the temporal lobe. In this second specimen, I've removed the brainstem and the cerebellum so that we can have a better view of the inferior surface of the cerebral hemisphere. Now, I just showed you placing 3 fingers along the lateral surface of the temporal lobe, and then to complete the picture of the temporal lobe, I'm just going to lay my additional 2 fingers right along 2 long gyri that we see on this inferior surface. So now I've got 5 fingers on the temporal lobe. On the lateral aspect, I've got a superior temporal gyrus, a middle temporal gyrus, and an inferior temporal gyrus. And then as we look onto the ventral and medial aspect of the temporal lobe, my index finger is representing a long straight gyrus that runs from the temporal lobe back towards the occipital lobe. This is called the occipitotemporal gyrus, and sometimes the posterior part is called the fusiform gyrus. And then my thumb represents a very interesting medial gyrus of the temporal lobe called the parahippocampal gyrus. In fact, the knuckle of my thumb is sort of sticking out just a little bit because indeed there's something that looks like a knuckle on this gyrus called the uncus. The parahippocampal gyrus folds in upon itself to form a really wonderful structure in the brain called the hippocampus. And we'll see that in cross-sections through the brain. So 5 fingers on 5 gyri in the temporal lobe. And now to complete our lesson on placing fingers on the gyri of the cerebral hemispheres, I've got yet a third specimen that allows me to work on the medial surface of the hemisphere. But to approach the medial surface, I want to begin again with the central sulcus. And you'll recall that I defined the central sulcus with 2 fingers on the lateral surface with the precentral gyrus, a postcentral gyrus, and the space between my fingers being conceptualized as the central sulcus. Now what I want to do is I want to reverse my approach to the central sulcus and let my fingertips wrap along the dorsal surface of the brain such that my fingertips come together in the part of the brain called the paracentral lobule. So now imagine that my 2 fingers are fused together. That's the relation of the pre and the postcentral gyri to the paracentral lobule. So that portion contributed now by my middle finger is the precentral gyrus, and the part contributed by my index finger is the postcentral gyrus. And again, those 2 fingertips or 2 gyri will fuse just above and in front of the branches of the cingulate sulcus. Now the rest of the frontal lobe can be conceptualized as having 2 long gyri. The cingulate gyrus that runs right on top of the corpus callosum, and then the gyrus that forms the dorsal margin of the hemisphere. This is simply the continuation of the superior frontal gyrus onto the medial face of the hemisphere. Now let's look at the occipital lobe. The occipital lobe is in this region of the brain, and it can be conceptualized as having 2 gyri that are somewhat parallel to each other. The inferior of the 2 is called the lingual gyrus, and this is a gyrus that forms something like a tongue shape on the bottom of the occipital lobe. Lingual means tongue. And then just above the lingual gyrus is a wedge-shaped structure called the cuneus gyrus. Cuneus is a Latin word that means wedge. Now just in front of the wedge is a gyrus that wraps around from the superior parietal lobule, and this we call the precuneus, which of course would simply mean in front of the wedge. So the rest of the medial face then is comprised of an occipital lobe defined by 2 gyri, a lingual gyrus and a cuneus gyrus, with a space between them being the calcarine sulcus. And then at about a right angle is the precuneus gyrus, with the space between the precuneus gyrus and my 2 fingertips, representing the occipital lobe, is a long, straight sulcus called the parietal occipital sulcus. Now, you may not have a human brain to wrap around your fingers, but if you're fortunate enough to have access to a brain model, I would encourage you to do this exercise. Perhaps you can even make your own brain model out of modeling clay, or perhaps even just with a round-shaped balloon that you can mark up and put your own fingers on the gyri to help conceptualize the complex anatomy of the cerebral hemispheres.